Hello grade 9. In this video, I'm going to tutor you on how to solve a quadratic inequality. Okay? Quadratic inequality uses the four inequality symbols. We have the greater than or equal to, less than, and less than or equal to. Okay? So, while the quadratic equation involves the equality symbol or the equal sign. Okay, so let's start. We have here 2x squared minus 11x plus 12 greater than 0. And we're going to solve for the solution set of this given inequality. Okay. So, when we are solving for the solution set of a quadratic inequality, we use the whole process of solving quadratic equation. Okay? So, the first step is to turn the problem into a quadratic equation. So, we change the symbol into equal sign. So we have 2x squared minus 11x plus 12 equals 0. Why do we need to turn the inequality into an equation? Because we're going to find our critical points. Critical points or boundary points or the zeros or the x-intercepts. Those terms mean the same, okay? So, we go back to the method of solving a quadratic equation. We have four methods. We have the square root method, factoring method, completing the square method, and using the quadratic formula method. Okay, so you can choose any of those four methods in solving for the boundary points of our inequality. Okay, so in this case, I'm going to use the factoring method because the quadratic equation is solvable by factoring. And the technique that I'm going to use to factorize the left side of the equation is the AC method or factoring by grouping method. Okay? So, this leading coefficient is the A. The middle coefficient is B. The constant term is C. Make sure your equation or your quadratic inequality is written in standard form. Standard form, all the terms are collected or written on the left side and the right side is 0. If there's a need to put all the terms on one side, you do that first, okay? So, our A is 2, our C is 12. Our AC, or the product of A and C, is 2 times 12, and it's equal to 24. Think of factors of positive 24 that when added, the result is equal to your B. Your B is negative 11. So, what factor pair of 24 will give you a sum of negative 11? We have negative 8 and negative 3. Let's double check. Negative 8 times negative 3 is equal to 24. Negative 8 plus negative 3 equals negative 11. Okay. Then we split up the middle term, negative 11x, into two terms, negative 8x, negative 3x. If we combine these two terms, we get negative 11x. Okay? So, our quadratic trinomial on the left side of our equation will become a 4-term polynomial. So, let's write the leading term and the constant term. Okay. Then, we group the terms. Let's group first and second terms. We also group the two remaining terms, the third and fourth terms. The preceding sign of 3x is minus. Be careful when grouping third and fourth terms, especially when the sign here is a minus sign. Make sure that when you distribute back the negative into the terms of the second group, this will be the result. So, if negative is outside the parenthesis, the sign of 12 inside the parenthesis should be negative. Let's double check. Negative times positive is negative. Negative times negative, it's positive. Okay. Next, after grouping, we factorize each group using the GCF method. So, GCF of the first group is 2x. Then we divide each term of the first group by the GCF. 2x squared divided by 2x is x. Negative 8x divided by 2x is negative 4. Minus. Factorize also the second group using the GCF method. GCF of 3x and 12 is 3. Then divide each term of the second group by the GCF. 3x divided by 3 is x. 12 divided by 3 is 4. To validate if your grouping is correct, you should arrive at a common binomial factor. So notice that we have a common binomial factor. It's x minus 4. We factor out the common binomial factor. So if you factor this out, we're left with 2x and negative 3. And then by zero product property, we equate each factor to 0 and then we solve for x. So the first factor is x minus 4, set to 0, and solve for x. We also set the second factor to 0, then solve for x. First, transpose negative 3 to the right side. It becomes positive 3. Next, We isolate the x, divide both sides by 2. We get x equals 3 over 2. Okay? If only this is a quadratic equation, we're done. But since we are solving for the solution set of a quadratic inequality, this is just actually our initial step. The whole process in solving quadratic equation is only a part of the whole process in solving quadratic inequality. Okay? These two values of x, the x-intercepts, the zeros, will be our boundary points or our critical points. Okay? So, the next thing that we need to do is to draw our number line, our x line. And then we're going to plot our boundary points. And it should be in order. Okay, so you put 2 tick marks on the number line, which is smaller. 3/2 is smaller. This is 1 1/2. And 1 1/2 is smaller than 4. So it should be placed before 4. Okay, so notice that the number line is being divided into 3 regions, 3 intervals. Okay, let's write down our 3 intervals. All the real numbers to the left of the boundary point 3/2 is to be represented by the interval x is less than 3 over 2. This interval means that all the numbers to the left of 3/2 are less than 3 over 2. Okay? This is our mid region or section. We represent this section by the interval x greater than 3/2 but less than 4. All the real numbers that fall within this section is represented by x greater than 3/2 but less than 4. And all the numbers to the right of 4 is to be represented by the interval x greater than 4. Okay? So, these 2 boundary points created 3 different intervals. Next, let's write down the factored form of our quadratic expression on the left side of our inequality. X minus 4 times 2x minus 3. X minus 4 times 2x minus 3. X minus 4 times 2x minus 3. Okay, next, we choose a test value for each interval. Test value is any value of x that falls under the interval. So, x is less than 3/2. Think of a number, any number that's less than 1 1/2, and you will use it as your test value. So for the first interval, I will choose 0. 0 is less than 1 1/2. You can also choose 1. Any number as long as it falls under x less than 3 over 2. For the second interval, x is greater than 3 halves but less than 4, I'll choose 2 as my test value. And for the last interval, x greater than 4, I'll choose 5. 5 is greater than 4. Okay? Next, you plug the test value into each of the factors and find out the sign. Okay? So if you plug 0 into x minus 4, this becomes 0 minus 4, and the result is negative 4. You just write the sign, so it's negative. If you plug 0 into 2x minus 3, the first term becomes 0 because multiplication by 0 is always 0. So you're left with negative 3. And the sign of the result is negative. Okay, next. Our test value is 2. So we plug 2 into x minus 4. 2 minus 4 is negative 2. The sign of the result is negative. Plug 2 into 2x minus 3. 2 times 2 is 4 minus 3, positive 1. The result is positive. Next, we plug the test value 5 into x minus 4. So 5 minus 4, positive 1. Plug 5 into 2x minus 3. 2 times 5, 10 minus 3, positive 7. Okay? So, if you multiply factors that are both negative, the product will be positive. If we multiply factors with different signs, one is negative, the other factor is positive, we get a negative product. And if we multiply factors that are both positive, our product will be positive. Okay? So, let's go back to our original inequality, 2x squared minus 11x plus 12 greater than 0. When solving for the solution set of this given inequality, we want the interval of x that make this inequality true. Okay? That means if you plug values of x into left side of this inequality, the result should be any number that is positive. Because if your left side is any positive number greater than 0 is always true. Okay? So, which of the three intervals will make this inequality true? In the first interval, numbers that are less than 3 halves will always give you a positive result for the left side. In the third interval, all real numbers that are greater than 4 will always give you a positive result on the left side of the inequality. So that means the intervals that will make this given inequality always true are x is less than 3 halves and x is greater than 4. So our solution set in inequality notation is x is less than 3 over 2 or x is greater than 4. We can also express our solution set using the interval notation. In interval notation, x less than 3 halves can be written as three halves negative infinity. This looks like the arrowhead pointing to the left, and this means all real numbers endless to the left. So we use the negative infinity. Okay? And the negative infinity always comes with parentheses. This is parentheses because it indicates that 3 halves is not included in the solution set. Okay? Or you replace the word or with the symbol for union. So it looks like capital U. In interval notation, x is greater than 4 can be written as 4 then positive infinity. It looks like an arrowhead pointing to the right. So this means all real numbers endless to the right up to infinity, positive infinity. Positive infinity always comes with parentheses. This is parentheses because it indicates that 4 is not included in the solution set. Okay? So the solution for this given inequality can be expressed in two different notations: the inequality notation or the interval notation. Okay? So notice that this interval, the middle interval, is actually not part of the solution set. It's excluded from the solution set because all the real numbers that fall within this interval would result to a negative value on the left side. And negative greater than 0 is never true. It's a false statement. That's why this is not a solution of the given inequality. Okay? So, if you have questions or you want further clarification, leave a comment. Please don't forget to subscribe to my YouTube channel. I am Tutor Marife MCP. Thank you for watching.